And welcome back, and we're on to the Corbett 5 a day higher plus, and we're doing this for the 3rd of January. Let's go with the first question. Okay, so the first question, one of those slightly misleading questions. It will hopefully be presented slightly better in an exam, but what this is actually saying is, if I write it in largest font, 25 to the power of minus a half. Now, minus a half means that you're doing two things. So if I write brackets, it's slightly easier to see. So I'm doing 25 to the half, and then I'm minus oneing it. Obviously, that's not math language, but you know what I mean. So to the power of a half means square root, and the square root of 25 is 5, and 5 to the minus 1 is 1 over 5. And that is the first question done. Next question. Prove. And then I need to prove that statement there is always a multiple of 3 if n is a positive integer. Well, even if you don't know what you're doing, you get a mark for this just for expanding. So if I expand the first bit, well, that's going to be 25n squared plus, well, 2 times 5 is 10, then double it is going to be 20n, and then 2 squared is 4. Now, you've got to be careful now because I'm taking away all of these. So take away 25n squared. Minus 5 times 1 is minus 5. Double it is minus 10, and that's a minus again, so it's plus 10. Be super careful with your double minuses there. And then minus 1 times minus 1 is plus 1, but it's still a minus, which gives me minus 1. And if we add these together, now the reason I say add is because I've put the minuses in already. So 25n squared minus 25n squared goes away. 20n plus 10n is going to give me 30n, and 4 minus 1 is going to give me 3. Now, what do I need to do? I need to show this a multiple of 3. So in other words, I need to factorize out a 3 from this equation here, which is going to give me 10n plus 1. And then I would state, now also I don't have a lot of space here, but I would state something like as 3 is a factor, statement, in other words, the thing I've started with. You could actually do like a little asterisk and say asterisk instead. Statement is divisible by 3. Question done. Next question. Rationalize the denominator. So this is just a nice straightforward skill, isn't it? So if you have a surd on the bottom and no plus or minusing, you multiply top and bottom by whatever that surd is. So top and bottom by root 2. Root 3 times root 2 is root 6. You multiply the numbers inside. Root 2 times root 2 is 2, and it's just going to give me root 6 over 2. Not a terrible question. Next question. Find the equation of the line that is perpendicular to 3x plus y equals 8 and passes through the point. All right, so this is, again, another one of these skills we just need to be quite good at. It doesn't actually say how to leave the answer, so I'll give you 2 different ways of doing it. First thing, I'm going to rearrange the original equation. So that's going to give me y equals minus 3x plus 8, which means the gradient for the original line is minus 3. And it means my perpendicular gradient is a negative reciprocal, which is going to be a third. Now, I'm going to use the y minus y1 method. So that's going to be y minus 5 equals a third x minus 1. The method you might use might be to put the values in and then find out what the c is and put the value. It's the same method. It's just a slightly rearranged sort of method. If you haven't seen this before, you'll use this a lot at A level. It's quite useful. Let's bring this together. So that's going to give me y equals a third x minus a third plus 5, which is going to be y equals, let's write that slightly neater, which is going to be y equals a third x. Now 5 is the same as 15 over 3. If I take away 1, that's 14 over 3. So that's going to be plus 14 over 3. Question done. Now I did say I was going to show you 2 methods. The other method is at this point here, I'll multiply both sides by 3, and that gives me 3y minus 5 equals x minus 1. And then I can collect my terms, so I can rearrange this to be, there's a few ways of doing it, but I could say x minus 3y equals, well, it's not going to be nice, it's going to be equals minus 4. Let's bring the 4 over, so it's plus 4 on this side is equal to 0. So both these, so let's say equation 1 and equation 2, unless the question tells you otherwise, both are acceptable, and well done if you got either. Next and final question of today. Well, by complete coincidence, I was teaching this today in school. Now, when you do one of these, you need to remember that you're doing 81 to the minus 3 quarters, and you're also doing x to the 8 to the minus 3/4. Now you don't have to do them separately, but it allows me to talk about the different things that are happening here. So this one means, well, the minus means 1 over, so I'm going to do 1 over. A quarter means the 4th root of 81, and then the 3 means I cube it. So in other words, you could think about it like this, couldn't you? You could think about it as 81 minus 1 to 1 over, then do the quarter, and then cube it, because 3 times a quarter times minus 1 is minus 3/4. If I try and resolve this, so the 4th root of 81 is 3, and 3 cubed is 27, so that's going to be 1 over 27. This one here is brackets, so I'm going to do 8 times 3/4, which is 8 divided by 4, which is 2 times 3, which is 6, with a minus, which is going to give me x to the minus 6. And let's put both of these together, and that's going to be 1 over 27 x to the 6. There's a few ways of writing it. You could do 1 over 27 times x to the minus 6, but either of those are fine. And that's today done. Again, as ever, really good little mix of questions here. So well done if you got them all, and if you didn't, you do know what to practice. Thanks all. Bye.